On Chapter 6, what we're going to talk about is sampling error, standard error of the mean, and something else called a confidence interval. For any of this information, basically what we're talking about is to what degree does the sample that we take represent the population we're trying to describe. Anytime that we take a sample from a population, there is a chance, a very strong chance, that the sample will not really look like the population. For example, if we're going to select a sample of all the fifth graders, depending on how good of a job we do, they may not really represent every kind of fifth grader there is, and we know that to be true. And the difference between these two things creates the error. The problem with this is the sample size that we select influences the amount of error that we have, and the type of sampling that we go through. Remember from the last chapter we talked about probability versus non-probability sampling. The quality of the sample also influences the error. So is the sample size and the quality of the sampling procedures that we go through that influences these. Questions often asked, was it better to have 300 non-random participants for a population of 1,000 or 50 random participants? It's really difficult to say. If the 300 non-random all look exactly alike and we know what our population looks like and they don't really look like the population, then that's not very good. Now, if we have 50 in our sample, but those 50 in terms of percentages look like our population, then sometimes it's better to have less numbers and a better quality sample. Suffice to say, it is very difficult to get to the point that we can have both quality and quantity at the same time. What we're talking about here is we're trying to reduce the sampling error. So one of the things that you can see that happens is when we have a very, very small population, yeah, we do have a very large sampling error. And as we get more and more people, even if it's not a high quality one, eventually if we get enough people, just because of our sheer volume, we're going to end up with a very small sampling error. One of the other things that you came across in your reading was something called the standard error of the mean. And there is a document that looks like this. Let me blow this up just a little bit so we can see it. If you think about when we take a sample, we have a population that we're going to select from, like this. And we're going to take a sample out of that group. So let's say the first time we do that, that's sample number 1. If we somehow could know that our population has a mean of 35 on some scale that we're measuring, we know that with a normal distribution we have a certain mean with a standard deviation, one below and one above. If we took just a small group of this population, the odds of us getting a mean in our sample here in sample number 1 that matches the mean in the population is not real good. We know we're going to miss it by a little bit. If we took another sample, sample number 2, the odds are that we're not going to get the same mean in sample number 2 that we did in sample number 1, and it's probable that this mean for sample 2 does not match that we know to be true for the population. We're missing it. One of the things I want you to notice is when we did this first sample, we missed it by 4 points. When we did the second sample, we missed it by 4 points. We take another sample, sample number 3. This time, we just happen to be able to hit exactly on the mean of the population with our sample. We take another sample, sample number 4, and that's 3 points below the mean. If we keep doing that over and over, eventually we would be able to create a picture in our samples that looks like this. We end up with a mean and a standard deviation for our samples. How far we miss that by is what causes our standard error of the mean. Just like we have a standard deviation for normal distributions, we could have a standard error of the mean for our sample. So if we have a small standard error of the mean, then that means that we're not deviating very much from the population mean. So this one, for example, has a very small standard error of the mean as opposed to this one. Now, we're not actually going to sample over and over and over. We just do it once. But statistically, there's a way to calculate how far we're missing it by. If we have a very large standard error of the mean, that means we've not done a good job sampling. And there's a lot of difference between what our sample is and what our population is. And I'm going to pause for just a second. I want you to look on page 119 in your Hucklebook. And it talks about two different examples. One, and this is an excerpt 6.1, and another one in excerpt 6.2. At the top of that, it says offenders in good health were on average a significant longer sentence of 62.90 months with a standard error of 5.4. That means that if we took another sample, we would have a chance that our group would have somewhere between, if you took 62.9 and added 5.49, that's 68.39 months. And if we subtracted it, 57.41 months. So that means if we took another sample, we feel pretty confident that it'd be somewhere between 57 months and about 67 months. Had that number been smaller, that would mean that we'd have an even better sample in our population. And the same thing down at the bottom. And this one time it does in percentage. Survival rate is 80.6 with a standard error of 4.9. That means that they think that the population is 80.6, but because of their sampling method, it's somewhere between about 76% and 85%. If you look on page 120 in your book, there's another way by which they could represent this, and this is kind of like a box and whisker plot that we talked about before. So under the control group, you have practice GRE scores, math scores, and practice GRE verbal scores. So that box, the black box, represents the mean of the group. The whiskers demonstrate the standard error of the mean, how far those are distributed from the mean themselves. So a shorter whisker means that we've done a better job sampling. The most important point to remember from this is the standard error of the mean is a representation of how well the sample looks like the population. The smaller we can get the sample standard error of the means, the better off that we are.